Hi guys, how do we solve this algebra problem? X plus 2 to the power 4 equal to x minus 1 to the power 4. This left hand side could be written as x plus 2 all squared times 2 equal to. Similarly, this right hand side could be written as x minus 1 all squared times 2. This implies that. Now, let us move this right hand side to the left side. So that will be x plus 2 all squared times 2 minus x minus 1 all squared times 2 equal to 0. Let's continue. Recall that a square minus b square is equal to a minus b times a plus b. Now, using this identity on this guy, you will notice that our a is x plus 2 all squared, while b is what? X minus 1 all squared. This entire equation now becomes this. What is a? A is x plus 2 all squared, x plus 2 all squared, minus b. B is x minus 1 all squared, x minus 1 all squared, close brackets, times a plus b. A is x plus 2 all squared, x plus 2 all squared, plus b is x minus 1 all squared equal to 0. Let's continue. If you expand x plus 2 all squared very well, you're gonna have x squared plus 4x plus 4 minus. Expanding this also very well, we're gonna have x squared minus 2x plus 1 in brackets. So let's close the entire bracket. Times. Now, let's expand this very well. We are gonna have the same thing we have here. S squared plus 4x plus 4. S squared plus 4x plus 4 plus, expanding this also very well, we're gonna have this s squared minus 2x plus 1 equal to 0. Let's continue. So, dropping these brackets, there should be a bracket here. Dropping these brackets, we have s squared plus 4x plus 4 minus times s squared minus s squared minus times minus 2x plus 2x minus times 1 minus 1. Close the brackets into s squared plus 4x plus 4 plus, dropping these brackets, we simply have s squared minus 2x plus 1 equal to 0. Let's proceed further. Clearly, s squared minus s squared, that goes off. We are left with 4x plus 2x, 6x, 4 minus 1, that is plus 3, times, let's add the common terms here also, s squared plus s squared, 2s squared, 4s minus 2x plus 2x, 4 plus 1, that is plus 5, equal to 0. Let's proceed further. This implies that 6x plus 3 is equal to 0, or 2s squared plus 2x plus 5 is equal to 0. Clearly, from this line, 6s equal to minus 3. If we divide through by 6, we simply have x equal to minus 3 divided by 6, x equal to 3 in 3, that is 1, 3 in 6, that is 2. We are left with minus 1 over 2. This is the first solution. S equals to minus 1 over 2. Let's call it x1. Now, let's consider this quadratic equation. We can solve this using completing the square method. Let's manage this side by completing the square method. The first thing we have to do, because the coefficient of s squared here is 2, so we have to divide through by 2. So let's divide through by 2. So that will be 2s squared divided by 2 plus 2x divided by 2 plus 5 divided by 2 equal to 0 divided by 2. 2 cancels 2. We have s squared plus 2 cancels 2. We have x plus 5 over 2 equal to 0. The second step is that we have to transfer this constant to the right hand side. So that will be s squared plus x equal to minus 5 over 2. Now, let us add half of the coefficient of x and at the same time square it to both sides. The coefficient of x here is 1. 1. So half of it will be 1 over 2. So we square it. So add 1 over 2 all square to both sides. S squared plus x plus 1 over 2 all squared equal to minus 5 over 2 plus 1 over 2 all squared. Let's put it further. I can combine this left hand side. So that will be x plus 1 over 2 all squared. That is, if you carefully expand this whole guy, x plus 1 over 2 all squared, you will have all of this left hand side back. This is equal to minus 5 over 2 plus 1 over 2 all squared. Let's continue. X plus 1 over 2 all squared equal to minus 5 over 2 plus 1 over 2 all squared could be written as 1 square divided by 2 square. So x plus 1 over 2 all squared equal to minus 5 divided by 2 plus 1 square, that is simply 1, divided by 2 square, that is simply 4. Let's continue. X plus 1 over 2 all squared is equal to, on this right hand side, taking the LCM is 4. 4 divided by 2, that is 2. 2 times minus 5, minus 10, plus 4 divided by 4, 1. 1 times 1, 1. So x plus 1 over 2 all squared equal to minus 10 plus 1, that is negative 9 divided by 4. Now, take square root of both sides. So doing that, we have x plus 1 over 2 equal to plus or minus square root of minus 9 divided by 4. X plus 2 equal to plus or minus. This whole guy could be written as square root of negative 9 divided by square root of 4. X plus 2 is now equal to plus or minus. I can rewrite this numerator as square root of negative 1 times square root of 9, or divided by square root of 4. Oh, sorry, there's a mistake here. This should be 1 over 2. Let's continue. X plus 1 over 2 equal to plus or minus. Don't forget, from the complex number, we know that square root of -1 is equals to I. So we have I here. What is square root of 9? That is simply 3 divided by square root of 4. That is 2. This implies that x is equal to minus 1 over 2 plus or minus I times 3 over 2. From this answer, we can obtain our s2 and s3 respectively. X equal to minus 1 over 2. Considering the positive sign, we have plus I times 3 over 2. Let's call this x2. This is our second solution. Also, considering the negative sign, we have x equal to minus 1 over 2 minus I times 3 over 2. So let's call this s3. This is our third solution. Therefore, all the solutions that we have for this algebraic problem are: the first one is x1 equal to minus 1 over 2. S2 is this guy, minus 1 over 2 plus I times 3 over 2. While S3 is this. S3 is equal to minus 1 over 2 minus I times 3 over 2. You will observe that we have three distinct solutions: one real solutions and two complex solutions. That's it for this video. Thanks for watching.